Everyone, today we're going to be writing and graphing inequalities. Before we write and graph any inequalities, let's go ahead and talk about the different symbols. The first symbol that we have is less than. We also have greater than. We also have less than or equal to, less or equal. And we also have greater than or equal. Just to get one quick piece of information out of the way, when you are trying to look at an inequality and decide what it means, if it automatically doesn't come to you, remember reading inequalities is like reading a book. If you read left to right, if you notice on this first inequality right here, it starts with the small end and then goes towards the big end. So if it's whatever it starts with is how I'm going to read it. So this one, small, less than. On this one, it starts with the big side, so that's the greater side, so greater than. So if you ever had a hard time reading those before, hopefully that helps. Next thing that I want to talk about is some key phrases that these inequalities stand for. Now, if I'm reading a phrase and I see the word fewer than, I'm going to know that is the same as less than. If I see the phrase more than, I'm going to know that that means greater than. If you see the phrase at most, or you see the phrase no more than, both of those phrases mean less than or equal to. For example, if I had at most 10 pieces of candy, that means I could have 10 pieces of candy or a smaller amount or less. If I had no more than 10 pieces of candy, the same would be true. I could have 10 or less. Greater than phrases include the phrase at least and the phrase no less than. For example, if I wanted at least 90% on a test or no less than 90% on a test, I would be happy with 90%. I would be happy with it equaling 90, or I'd be happy with it being greater. Those are my symbols, so let's go ahead and write some inequalities from phrases. If I'm writing the sentence, a number C plus 9.4 is greater than or equal to -6, I'm going to first find my word that represents an inequality, greater than or equal to. I'm going to write that symbol down, greater than or equal to. And on either side of my inequality, I'm going to write my phrase that's on either side of that phrase. So C plus 9.4 and -6 on the opposite side. And that's my inequality. Let's go ahead to example B. 6 is greater than a number P minus 8. So here's my greater than. I'm going to write my inequality. And it says 6 is greater than a number P minus 8. All right, last example. 10 is no more than the sum of 3 times a number y and 4. Now that's a mouthful, but let's go ahead and start with identifying our symbol, no more than. If you want no more of something, you're okay with having that much, but you want less than that. So it could equal or be less than. So less than or equal to. 10 needs to be less than or equal to. Now here's the second side, and it's a little bit harder, but let's break it down. Sum means I'm going to add. Whenever you see the word sum, whatever comes after is what I'm going to be adding together. And the word and tells you where to break up that with a plus sign. So I'm going to write a plus sign, and it says the sum of 3 times the number y, that's going to go on one side of my plus sign. There's the word and, so I have my plus sign, and 4 goes on the opposite side. So there's my next phrase. The next thing I want to talk about is how to determine if something is a solution of an inequality. In order to determine if something is a solution, plug it in. If I want to tell if negative 6 is a solution to this inequality, I'm going to plug it in, and I'm going to plug it in for my variable. So here we go. Negative 6 plus 4 is less than negative 1. I have to simplify in order to know if it's true. Negative 6 plus 4 is negative 2. I'm going to look at that inequality, and I'm going to say, is negative 2 smaller than negative 1? And yes, it is. So is it a solution? Yes. Let's go to our second example. 10 is less than or equal to, I'm still trying to decide if it's negative 6 is a solution. So in for m, I'm going to write a negative 6. 3 minus, I do need to keep the minus, negative 6. Because there is no other operations going on with that negative 6, I can add my negative, which means subtract my negative, which means I'm going to add. 10 is less than or equal to 9. Wait, is 10 less than 9? No, it's not. Is 10 equal to 9? No, it's not. And because neither of those things are true, the answer is no, this is not a solution. Let's answer this last one. 4x, when you plug something in with a variable, remember to put it in parentheses. I'm going to multiply. Negative 24 minus 25 is greater than negative 2, and I'm going to simplify that. Is negative 49 greater than negative 2? And the answer to that is no, it is not. And so no, negative 6 is not a solution to that inequality. If I want to graph an inequality, what I'm looking for to make is a picture of all the different possible solutions for x. What could I plug into x to make this inequality true? So to begin with, a couple things that you need to know is the following. I am going to make a number line. On my number line, I'm going to place this number. So I'm going to place 3 on my number line. You always need to include a number that's bigger and smaller, just so we have a frame of reference. So I know all the numbers that are bigger and smaller than 3. As I read this inequality, I'm going to read it, I'm going to read it left to right. X, all the values that x can be, need to be greater than or equal to to 3. So if my values need to be greater than or equal to 3, it can be one of my solutions can be 3. So hopefully you remember from 7th grade. But I'm going to put a closed dot at 3, and my arrow is going to point the direction that is greater than. That's representing that any of the numbers above 3 could be solutions. Now just to recap, I put a closed dot whenever I have something that is greater than or equal to or less than or equal to. And I'm actually going to put an open circle if I have less than or greater than. So things that are not equal to. Like my next example, B. I'm going to write my number line. Here's my number that I'm going to put on my number line. Please be aware of the order on your number line. It goes negative 3 is larger than negative 4. And negative 5 is smaller than negative 4. Now, y cannot be negative 4. So I'm going to put an open circle. Open circles mean that it cannot be that value, but I'm going to draw my arrow in the direction that my solutions are true. So I'm trying to decide what I could plug in for y. I prefer to rewrite this inequality so that my variable comes first, so I can read it left to right. Y, this symbol needs to make sure that the sign is still facing the same direction as towards my variable as it was to begin with. So y is less than negative 4. And now that I see it, it says y is less than negative 4, so I'm going to draw my arrow in the direction of less than. If you don't want to rewrite it, you can always read backwards and see that it says y you hit the small side of the inequality first. Y is less than -4. And that's how to graph inequalities. So let's go ahead and look at a couple of graphs and then do the reverse. Let's write those inequalities. So the graphs below show the height restrictions in h. So we're going to use the variable h when we write our inequalities for 2 rides at an amusement park. We're going to write inequalities that represent the height restrictions for each ride. So if I'm looking at ride A, notice there's a closed dot at 48 and it's going up. So what is that saying? That's saying that if you are 48 inches tall, or all these numbers are greater than 48, then you can ride the ride. So my inequality is going to look like so. H is greater than, well, can you equal 48 inches? Go to this graph. It's closed in, saying that it can equal 48. Ride B is saying that in order to ride B, you need to be, okay, we're starting at 52. H is less than, because my arrow, all the numbers are going smaller than 52, cannot equal 52. So I'm not going to add that or equal to. So you can imagine ride A, you got to be a big kid to ride the ride, and ride B might be in Kittyland, and you need to be smaller than 52 inches. Let's continue from a word problem. So here we go. Matt is climbing a mountain. When his elevation is higher than 1,600 meters, breathing is difficult. We're going to write an inequality that describes h, so that's going to be our variable, the elevation at which breathing is difficult for Matt. So it's saying when his elevation is higher than 1,600, it's difficult. So 1,600, and 1 would be harder, so anything higher than 1,600. So h greater than 1,600 is when it's going to be difficult to Matt. Notice it didn't say higher than or equal to 1,600, or it didn't say it starts getting hard at 1,600. It just says higher than. So no or equal to. To cook a steak to medium rare, it needs to have an internal temperature of 135 degrees Fahrenheit. A lower temperature and the steak will be considered undercooked. We're going to write an inequality to represent all the possible temperatures T of an undercooked steak. So the variable that we're going to use is T. And we're trying to represent the undercooked steaks. So if it's undercooked, do we want it to be higher than 135 or lower? Well, it says a lower temperature and it will be undercooked. So T needs to be less than, okay, if it's 135, we're good, so we're not going to put the or equal to 135. All right, last example. Kennedy collected 90 pieces of candy on Halloween. Her sister Tara stayed out later and collected at least 30 more pieces of candy. Write an inequality that represents the possible number of candy bars, T, and it's capital this time, so I'm going to make sure I write a capital T, that Tara collected. Now, it says the phrase at least. So did Tara collect more or less than 30 pieces more? She may have collected more, then she may have collected exactly 30 more pieces of candy. We don't want to just write 30. She collected at least 30 more pieces of candy. Well, what's 30 more than 90? She collected, if it's 30 more than 90, she collected at least 120. So I do have to take 90 and add 30 to it before I can finish my inequality. And that's it. If you have any questions, please reach out to your teacher. Thanks.